Hello, everyone. This is Wyatt from Constellation, here to kick off the first in a series of demos on what Constellation does differently and what we are most excited about in our next big release here. The first thing in line with that that we're going to be talking about today is our double spend protection. That's a pretty canonical problem. How can we prevent malicious user from minting tokens and then trying to fool the consensus process? So, one thing that is a little bit different about Constellation is that we're able to perform consensus rounds at the same time or in parallel. And in order to achieve that, what we need to do is implement some type of a linear ordering or some type of a topological ordering, if you will. In this sense, they're both the same between the transactions created for any specific address or account. So specifically speaking, yeah, if we were to, for instance, send two transactions and that got into two different consensus processes, how could we determine which one goes first, and how are we able to apply some type of validation criteria if there's no order of the operations? So what we do is we create a reference in each transaction to each previous transaction. That actually goes directly in the payload, and that is what's used when we create a signed observation edge, which is the hash that we use for validation. So you can see right here that there's actually, this right here is just a dummy last transaction ref, but since this is being used twice for one address, this would account or constitute a double spend. So what happens here is inside the transaction, we actually create, the edge, so we create this edge, which is the hash used for validation. And you can see that the actual payload here for that does contain the last transaction ref. So that is what we use in order to create a linear account chain. And that's how we're able to perform consensus in parallel, which is really the key to all of our scalability. So without diving too far deeper into that, I wanted to just show you guys a little snippet from our end-to-end test, which is sort of like a local unit or a local simulation where we spin up multiple nodes all at the same time. So we get sort of like a bird's eye view in the actual state of every node. So it's really helpful for us to test. And we have here as namely a task where we create two double spends. We want to identify whether or not the cluster is able to identify, and then handle that accordingly. So what I've done here is I've set a breakpoint which stops the execution flow, right in the middle. So it allows me to inspect the state. And right now I'm actually just going to move directly to, right now we're stopped at the creation of the double spend. So right now I'm going to move a little bit further down and, basically wait to see, whether or not we're able to notice that double spend is created. So moving a little bit further down. I also have some logs here that we can take a look at as well. So if you want to take a look, you can see specifically that we have a double spend transaction that was submitted, which is lovely. And we should be able to see that there are blacklisted addresses that have been identified across the different nodes. Oh, really, huh? Oh. Interesting. Well, there we go. We just identified the blacklisted address. That's really weird. It takes a while for the... it's like the app.log isn't updating. Anyway, we're able to see here directly in the actual standard app that we will identify the blacklisted address. And specifically, we can see that the double spend transaction also obviously was oh, there we go. Oh, there we go. Wonderful. All right, so you guys were able to just see the actual double spend prevention happening live. I just created 2 transactions, sent it into a simulation cluster, and you guys can see in the logs that we were able to identify the specific transaction in question. So that's the first in a series of demos, some of the stuff that makes this different and that we're really proud of. The next one that we have cooking is very related to scalability as well, although this actually is going to get into the, basically how we're able to configure different types of TPS, if you will, based upon the kind of application that we're using Consensus for. So great. So I'm excited to share that with you guys next week. I hope you guys had a great time. And yeah, see you guys soon.